Hello, good evening. So this is my final module, Capstone project, classification, airline passenger referral prediction. So let's dive into the project. So we have been given a data set of data airline reviews, which is in the XLSS Excel format, and that's why when loading it, we are using the engine of OpenPY Excel. So we have loaded the dataset into a data frame. We are doing the df.head to check the first five rows. Then we are doing the necessary due diligence like save info. From there we can get some how many non-null objects are there and how many null objects are there. From there we are finding the sum of the duplicated values and dropping the duplicated values. Then we are dropping the missing values or null values. So in the end, here we are finding the number of null values in each column. So aircraft column has the most number of null values. Not many people mention the aircraft model, that's why. So we are dropping the null values, then we are checking the shape. In the end it has this much of rows and 17 columns. So in next we are doing all the necessary thing like df dot columns, checking the column names, df dot describe, and other things. We are checking the value counts of the aircraft column, seeing that most number of aircrafts are A380, then Boeing 777, A330. Then we are going for variable description, which I have described. Then we are checking the unique values for each variable. Then we are doing data wrangling. So what we are doing in data wrangling, we are checking the value counts of each variable and how many values are there. So looks like all the ratings are from 1 to 10 in overall or 1 to 5 in other columns, and they are pretty well dispersed around the rows and columns. So next we are doing data visualization. In data visualization, we are checking chart 1. We are checking the we are grouping by the airline and finding the mean overall rating. So you can see that from this we can see that Aegean Airlines, these EVA and ANA, all Nippon, these all have the highest rated overall rated airlines, while these are the lowest rated and these are in the middle. Likewise, we have done a word cloud of all the words that are coming in the customer review, which is a text based column. So in that these are the bigger words are the ones which are the most used in the customer review column. Then in chart 3 we are doing all the bar graphs of different columns. We are seeing how many of the count value count. Then we are doing group by of airline and checking the other ratings like seat comfort. We are checking which airlines have the better seat comfort and which have the lower. Then we are checking the cabin service rating, same way. Then we are checking the food beverages rating. So Aegean Airlines is coming at top in all of them, and Spirit and Frontier are the ones which are falling behind. So we are doing the entertainment here also. Aegean is pretty ahead, while Emirates is the best, gives the best entertainment. Frontier, Spirit, these are always behind. And then we are checking the ground service rating, which is also a similar bar graph. Since we have done ascending equal to false, it arranges the bar graph in this way, from highest rated to lowest rated. Then we are doing a correlation heat map. From this we can see that overall and seat comfort, this is correlated by 0.77. Higher the number, the better the correlation. Since overall versus overall, which is 1, it is the same column, these all the diagonals will give 1, while the rest of the combinations, the higher it will be, the more bluer it will be. So looks like the lowest is around 0.52, which is ground service and entertainment. These are not much correlated, as we can figure out from our general knowledge. Like ground service doesn't mean there will be good entertainment, but since all entertainment will be good, so food and beverages might be good. So that is 0.78, like that, overall and food beverages. So next we are doing a pair plot. Since it is all the ratings of 1 to 5, all the pair plots are coming like this. Since it's rating from 0.5, they are all discrete values, that's why they are coming separated dots. Then we are doing hypothesis testing. We are providing a null hypothesis. First we are doing then alternative hypothesis. Then we are doing one sample t-test. For the first test, we are finding that the p-value which is greater than 0.05, hence we are accepting the null hypothesis. Therefore the overall rating is let's say we are accepting the null hypothesis that the overall rating is like this, is equal to the sample mean is equal to the population mean. So next we are going to the second hypothesis test. We are also doing one sample t-test once again. Here also the p-value is coming greater, hence we are accepting the null hypothesis. In third test we are doing a t-test independent, which is a two sample t-test. We are comparing the samples of two populations, and then we find this. We are accepting the null hypothesis because p-value is coming greater than 0.05. So next, feature engineering and data processing. I have already handled the missing values. I have already handled since there are no outliers, because they are the ratings are in range from 0 to 10 or 1 to 5. So categorical encoding, we are doing categorical encoding for only one column which is recommended, which is in the form of yes or no. So we are encoding it into 1 or 0, which is required for the machine learning algorithm. Then we are doing the textual data processing. There is a textual data column called customer review, and we are doing a sentiment analysis on this. We are using the analytical library. We are removing the stop words. We are tokenizing the sentence. We are doing stemming and lemmatization, all these things here, preprocessing in this preprocessed text function. Then we are doing the sentiment analysis using the analyzer. So we are getting the sentiment. So these are the sentiments and these are the recommended. These are the sentiments of the this is the sentiment 1, which means it is a positive rated review, and 0 means it is a negative rated review. So next we are doing the machine learning thing. First we are taking the independent variables and the dependent variables, and then the dependent variable is recommended, and independents are these ones, which are the ratings and the sentiment analysis which we have done. We are also including that into our independent variables. Then we are using a random forest classifier, which is a classification algorithm, and then we are fitting the model using our X train, Y train, and predicting. We have also done the train test split here, which separates the X and Y into training and testing parts, which are used later. So training is used for training and testing is used for testing the model. So ML model. So next we are doing the evaluation metrics like accuracy, precision, recall, ROC, AUC score. Also we are plotting the false positive rate and the true positive rate to get the ROC AUC curve. So this is no skill and this is random forest. Next we are going and doing cross validation and hyperparameter tuning. So CV equal to 5, it is using 5 cross validation modules, and then the grid search CV, what it does is it uses all the combinations of this param grid, all the parameter combinations, and find out the best parameter combination. So here we can see that it has found the best parameters, which is max depth equal to 5 and n sample split equal to 4 for this scenario. So again we are training the random forest classifier with the same amount, so which is the best parameters, and we are seeing the precision score, which is 96.49, which is greater than what we had gotten here, 95.55, because we have got the best parameters here. That's how we are doing the hyperparameter tuning. So same way we are doing that thing. Then we are again we are training a logistic regression model. We are doing the same thing: accuracy, precision, recall, and ROC, AUC. Then we are plotting the ROC, AUC curve. All the curves are looking like the same because they are all being trained similar way, though the models are different, which is because of the data set. Cross validation and hyperparameter tuning. So we are doing the same thing, cross validation and hyperparameterization, same thing again for this, but here we have used one time randomized search CV. Previously we had used grid search CV. What is the difference between grid search CV and randomized search CV is that random search CV uses random number of random parameters from this list, while grid search finds all the parameter combinations. So in naming model 3 we are doing Gaussian NB, which is a naive Bayes model. So we are doing fit and then predicting, then we are doing the same ROC score and false positive rate. Then we are doing the cross validation and hyperparameter tuning again. So in grid search we have a hyperparameter called var smoothing, which we get, which value we get, which is this is the one we get. This is the value which is the best suited for the model. So it gives the best performance. So that's how we have done all the things, and the evaluation metrics we are using, I have written it there. And all the models, all the three models out of this, we checking the evaluation metrics, we have seen that the logistic regression is the best performing model here because the data set is not so complex. So that's my guess, and here I have added the conclusion. So that's all from my side. Thank you very much.